Hi, welcome to 1.3 Elemental Composition of Pure Substances. This is where we're going to explain quantitative relationships between individual element composition in a compound by mass and find empirical and molecular formulas. So, a pure substance is one with a constant composition. Right? Pure substance can be an element or a compound. So constant composition. So here is a table that kind of describes what a pure substance is. It can be a single atom or a single element made from any element. So here we have magnesium, zinc, neon. If you have more than one element, ionic compounds, metal, nonmetal, or a molecular compound, metal to nonmetal. Here's some examples of a pure substance. And any atoms, individual atoms, when they're dissolved or they become an ion, is also a pure substance. We have also this thing called the law of definite proportion, which states that compounds with the same elements and the same proportion are the same compound. Now, because of the law of definite proportion, you can find percent composition from that and use percent by mass of each element that makes up a compound to find empirical and molecular formulas. Okay, so empirical formula is the simplest ratio, where molecular formula is the actual formula of the substance. Now, we did not get to this particular topic in regular chemistry, but it is part of the stoichiometric unit. So this might be something a little bit new. So you definitely need to know the steps. So I'll put a little star here. And then empirical formula, we can assume that if we're given percents, they should add up to a 100-gram sample. Okay? If we add those percents and get like 99.99, we can still convert percents into masses to be able to find empirical. Now, when we're determining molecular formula, we can only determine if we're given the molar mass of the substance in the problem. All right? So down here, find the mass of the empirical formula. So we got to do all these steps to find the empirical formula, and then we find the molar mass of that. And then step B, this molar mass that they're talking about is the molecular mass given in the problem. And we divide that by the empirical formula mass to find what we call the multiplier factor. Then we take that multiplier factor and multiply all the subscripts in the empirical formula by that value, and then this, doing all this, gives us the molecular formula. Okay. So really, this is all math, and it's just these steps, and this is one of the things where you have to practice this to learn it and understand it. So that's why there's not very many notes, and it gets right into the practice. Okay, so I'm going to put this paper, the second sheet, off to the side. So I'm going to do the I do and the we do, and then I'm going to go through each one of the problems and kind of give you clues and start setups on how to solve the rest. Okay, so for the I do, a certain sugar used in treating patients with low blood sugar has the following chemical composition. 40% is carbon, 6.7% is hydrogen, and then 53.3%, that should be a percent sign, is oxygen. What is the empirical formula? Now, you might have noticed I was jumping between a few different colors. So I am going to try to do these in different colors. Hopefully they show up differently. So if I take 40 plus 53, that's 93.3, plus the 6.7 gives us 100%. So we're just going to convert those into grams. So 40 grams of C. Okay. And then the next one was hydrogen, so 6.70 grams of hydrogen. And then we've got 53.3 grams of oxygen. All right. So that's the first step. Make sure your percents will add up, and then you convert them into grams. Okay. So we have grams here, and we got to get all of these into moles. So this is a simple grams of the same substance going to moles of the same substance. And normally I would put all these givens over 1, but I'm going to forego that and just go to the next step. So we multiply this by 1 mole of carbon divided by the mass of carbon. And when we do that, grams cancel, and we get moles of carbon. So essentially, I'm going to take 40 divided by 12.01, and I get 3.330557. All these long numbers for the moles. So I'm going to go 3 past the decimal. Right? You want to round, but you don't want to round to like just 1 past the decimal. So 3.331 mole of C. Then hydrogen, 1 mole of H is 1.01 grams of H. Grams cancel. So 6.1 or 6.7 divided by 1.01 gives us 6.6336. So again, I'm going to go 3 past the decimal. So that is 6.634 mole of H. And then the last one, oxygen times 1 mole of O over 16 grams of O. Grams of O cancels. 53.3 divided by 16 is 3.331 mole of O. Okay. So that's the first step. Okay. Assume you're given a 100-gram sample, change the percents to grams. For each element, take grams divided by its molar mass of the element to get moles, and then divide each mole value by the lowest values. If you get whole numbers within 1.1% of a whole number, just round. If not, you need to do a multiplier factor that gives you whole numbers for all. So D is like the multiplier factor that we call, but if you can divide by the smallest mole number and get whole numbers, then you stop at C and you get your empirical formula. All right. So let's do that one, dividing by the smallest mole number in red. Okay. Now we got 3.31 and 3.331, so it's the same number, and that's the lowest one. 331 equals 1. 3.331, that's going to be, 6.634 divided by 3.331 gives us 1.9999, which I'm just going to round that to 2. And then, of course, 3.31 equals 1. So we got whole numbers. So my empirical formula is 1 carbon, 2 hydrogen, and 1 oxygen. Okay. Now it says the molar mass of the compound is 180 grams per mole. What is the molecular formula? So this mass that we have right here, that's the molar mass of the molecular formula. Okay? So, if you watch the video, she does it a certain way. And if that makes more sense to you, that's fine. But I'm just going to use this, where I take the molar mass that's given in the problem and divide it by the empirical formula mass. Well, that means I got to find the empirical formula mass of this. So, the empirical formula mass, CH2O, well, I can just put that in. 12.01 plus 2.02 plus 16 is 30.03 grams per mole. So I'm going to take 180 grams per mole, divide it by 30.03 grams per mole. My units cancel, okay? And I'm just going to zoom this in just a little bit so you can see the yellow a little bit better, okay? And so 180 divided by 30.03 gives me a multiplier of 5.9940. So I can just round that to 6. So I'm going to take this 6 and multiply CH2O, and I get C6H12O6. And that is my molecular formula. Okay? Pretty straightforward. Right? Now, for the we do, I'm going to do it the way she does it on the video to show you. If that makes more sense to you, great. You can do it the way I did it here, which I think is the easiest, or you can do it the way that she showed on the video. So this problem also asks you to find the empirical formula of a compound that has so much carbon, hydrogen, and phosphorus this time. So we're going to convert these into grams. So I'm going to do the same thing that I did up here. So 56.5 grams of carbon times 1 mole of carbon, 12.01 grams of carbon. And when I do that, I get 4.7044. So 4.7044 mole of carbon. Okay. I don't have enough room to do all three, so I'm going to do them across here. So then 7.11 grams of hydrogen times 1 mole of hydrogen divided by the molar mass of hydrogen. Grams of hydrogen cancel. So when I take 7.11 grams of hydrogen divided by its molar mass, I get 7.0396 mole of hydrogen. And then 36.4 of phosphorus. Let me do that down here. Okay. 36.4 grams of P times 1 mole of P. And the mass of phosphorus is 9697. Okay. And when I do that math, I get 1.1753. So 1.1753 mole of P. Okay, now if I look, this mole number is the smallest. So I'm going to divide all of these by that. So I'm going to put this in red. What is it? 1.1753. 1.1753. It's going to give me one here. Divide this by 1.1753. So I get 1 for the phosphorus. And then when I divide by hydrogen, that gives me 5.9999. So I'm just going to round that to 6. And when I do carbon, I kind of ran out of room here. When I do carbon, I get exactly 4. So I'll just do this number up here, 4. So my empirical formula is C4H6P, and we don't put the 1. Okay, we never put 1 for subscripts. You might be wondering, well, how do I know if carbon goes first or hydrogen or phosphorus? The way you write the empirical formula is the way it's written in the problem. So since carbon comes first, we put carbon first, then hydrogen, then phosphorus. All right, so here is my empirical formula. So the compound has a molar mass. So again, this molar mass is the molecular mass. Okay. And we've got to find the empirical mass of C4H6P. Okay. Now, you know, it's basically C times 4 plus H times 6, the mass, plus 1 times P. Okay, so I'm going to do that on the calculator. Clear this out. 12.01 times 4 plus 6 times the mass of hydrogen is 6.06 plus 1 phosphorus, 30.97. So we have a empirical mass of 85.07. So 85.07 grams per mole for the empirical formula. Okay. Now, the way she does it on the video, this teacher does it, is essentially you want to find the multiplier step. So we want to solve for x. X times the empirical mass, 07, okay, grams per mole, equals the molecular mass. Okay, now we can, it's the same thing. To isolate x, I got to divide by 85.07, 85.07 grams per mole cancel. So then x equals, and it basically gets the molecular mass on top divided by the empirical mass, which is what I just did up here. So whatever makes more sense to you, all right? I personally like this. It doesn't have to go through this whole thing. You just take the molecular mass given in the problem, divide it by the empirical mass. All right, so when we do that, we get a multiplier of 2. So the molecular formula is we take 2 times this. So 2C4H6P becomes C8H12P2. And that's your molecular formula. Okay? All right, so that is the I do and the we do. So let's go through the rest of the problems, and I'll kind of talk you through how to solve them real quickly. Okay? So basically, this is find the empirical formula. It's not asking for molecular, so you can convert these percentages into grams, and then divide by the molar mass of oxygen to get a number, the molar mass of hydrogen to get a number, whichever mole number is smallest, divide by that to get a subscript if it's a whole number. If it's not, you got to go through the multiplier step. Okay, and I'm going to zoom this out a little bit so we can see all the problems. So you should get whole numbers on that one. Number 2, arginine is one of the amino acids. So again, it gives you percents. Go through the steps of converting those to grams, dividing by the molar mass of the element to get into moles. Take the smallest mole number and divide by everything by that number, and you should get whole numbers on that one. When you do that, then you've got to find the molar mass of the empirical formula and take the molecular mass, divide by the empirical to get the multiplier, and then apply that multiplier to the empirical formula. Okay. All right. Let me move this out of the way. Number 3 tells you the empirical and empirical and molecular formulas of urea are the same. So it gives you the percentages. So you got to convert those into grams. Get them into moles by dividing by the molar mass, and then divide by the smallest whole number, or mole number. Once you do that, you should get whole numbers again, and that will give you your empirical formula. And again, just write the empirical formula in the same order that it's written in the problem. It might not make sense, but that is the best way to do it. That way you keep things straight. Now, if you don't have enough room on the paper, do your work on a separate paper and then put your empirical formula on there and you can check it with the key. All right, number 4 is going to be the first one where you might not get whole numbers. So you're going to take these percentages, convert them into grams again. So 43.642 grams and 56.358 grams. Divide by the molar mass of the element to get to moles of that element. Look at the smallest number, mole number for phosphorus and oxygen, and divide by that number. And when you do, you will not get whole numbers on number 4. So you got to do the multiplier step. So look at the numbers you have. Start with multiply by 2. Does that get you to a whole number? If not, multiply by 3. Does that get you to a whole number? And then once you get to a whole number, then you can write your empirical formula. And then again, find the mass of that empirical formula. Take this number and divide by that empirical mass to get the multiplier for how much to double or triple or quadruple the empirical formula to find the molecular. Okay. Number 5, emeralds are composed of 4 different elements in a fixed proportion. So again, it gives you percents. Convert those percents into grams. So 5.030% becomes that in grams of beryllium. Divide by the mass of beryllium to get to moles of beryllium. And do that for aluminum, silicon, and oxygen. Look at which number is the smallest mole number between those 4 elements. Divide everything by that smallest mole number. And this is another one where you will not get a whole number at the end of that. So you got to do the multiplier step on this. So whatever numbers you get, start with 2, multiply by 2, see if you get whole numbers, then 3, 4, however far up you need to get, and then you'll find your empirical formula. Then it says calculate the molar mass. This is just asking you to calculate the molar mass of the empirical formula when you get it. Okay. All right, and then number 6 and 7, I didn't give you a lot of room for these. You don't need a lot of room for these, but if you can't get the iron and oxygen, convert those percents into moles or into grams, and then divide by their mass to get them into moles, and divide by the smallest mole number, then do it on a separate piece of paper. But it's basically asking you to determine with those percents, do you have FeO, Fe2O3, or Fe3O4, and you've got to determine which iron oxide was analyzed with those percents. Number 7, serotonin is a chemical in nerve cells that basically runs part of your body. It gives you percent of hydrogen, carbon, and nitrogen, and then an oxygen. Calculate the empirical formula. Now this one has hydrogen first. So I do want to caution you with this. Carbon should be first. Before I didn't realize hydrogen was first here. So go ahead and switch. So carbon should be first, then hydrogen, and then your nitrogen is third, and then oxygen is fourth. So when you do your, when you write your empirical formula, it should be C, H, and O, and you want to have your subscripts. Okay, so C, subscript, H, subscript, N, subscript, O. Right? So I apologize for that. I just realized that hydrogen came first. If you put hydrogen first, it's not that it's a bad thing, but if hydrogen is first, it's an acid. And serotonin is not an acid, so carbon has to be first in the empirical formula. And that is it. You could also do the work on the back and use the back sheet here, but that is your notes for topic 1.3, elemental composition of a pure substance, and I will see you in class.